My name is Bryson Wingate, and this is my game called Echo Vault. Echo Vault is a top-down survival strategy game where the player protects the vault by manipulating guard behavior with temporary sound beacons. The project was designed around two interacting gameplay systems that create the game's difficulty curve. And now I'll start the game demo. Now, when I press start, the three guards will automatically begin wandering the room. They don't automatically go towards the vault. They just wander around until they detect a sound source. Now the vault will constantly produce sound, and the player can, as you can see, can click anywhere to place temporary sound beacons, and these beacons will compete with the vault for the guard's attention. As time passes, the vault's sound becomes stronger, and every 15 seconds another guard will appear. And to balance the increasing difficulty, the player gets one active beacon for every two guards on screen. Then this allows the player's tools to scale while still requiring strategic placement. Now I'm gonna let this play out because obviously I'm about to show you that hey, you can lose. Now for the vision for Echo Vault was to create a game where the player influences enemies instead of directly controlling them. The player fantasy is outsmarting the guards through planning and prediction rather than combat or fast reflexes, and the project was intentionally focuses on a single screen with wandering guards, temporary sound beacons, increasing vault noise, a survival timer, a HUD, restart functionality, and separate files. Now, features like multiplayer, um, multiple maps, and story mode were intentionally left out so the project could focus entirely on the interaction between the two systems. And our success was defined by our players understanding the beacon mechanic quickly and recognizing that sound manipulation, not combat, was the core gameplay. Now down to the systems architecture. The architecture centers around two gameplay systems. The first would be the sound source system. This system owns the vault sound level, vault sound radius, beacon placement, beacon cooldowns, beacon duration, and number of active beacons. The second is the guard attention system. This system basically owns the guard's wandering, the sound detection, target selection, and then the movement. Now, supporting systems such as the renderer and the game state manager are responsible for drawing the game, tracking the timer, and handling win and loss conditions, but they don't actually create the gameplay by themselves. Now down to the mechanics. The primary mechanic is competing sound sources. Now, when a player clicks the screen, a temporary beacon is placed, and like I said, the beacon competes with the vault as another source of sound. Now, each guard constantly evaluates nearby sound sources and decides which one to follow. Several values are tunable, including the guard speed, the beacon duration, the cooldown, the vault sound growth, guard time, guard spawn timing, and total survival time. And these values change several times during development while balancing the game. Now down to the player experience design. The intended player experience is challenge, discovery, tension, and mastery. The players will first discover that sound changes the guard's behavior, and as additional guards appear and the vault grows louder, the player begins predicting movement and planning beacon placement ahead of time. And the positive feedback loop rewards good beacon placement with longer survival, while the negative feedback loop gradually increases pressure through louder vault noises and additional guards. Now for technical specifications, the project primarily uses three objects. The guard object stores position, speed, movement target, and current behavior, while the beacon target stores its position, sound strength, and remaining lifetime. And lastly, the vault object stores the position and the current sound level. Now, important algorithms include guard target selection, beacon exploration, vault noise growth, time guard spawning, and wandering behavior. And the game was built using HTML, CSS, and vanilla JavaScript. basically. Now, for our design difficulty curve. Now, the game begins with only 3 wandering guards so that players can understand the mechanics. But as the game progresses, the vault will gradually become louder, making it increasingly difficult to lure the guards away. And then every 15 seconds, another guard is added to the room, increasing the amount of attention the player must manage. But to balance this increase, the player gains 1 additional beacon for every 2 guards currently alive. And together, these mechanics can create an increasing level of pressure without completely introducing new gameplay systems. Now, for the UI and flow, the game will begin at the start screen. Pressing start begins the gameplay, and during play, the HUD displays the survival timer, vault noise, beacon information, and game status. The player wins by surviving 90 seconds, but the player also loses if any guard touches the vault. And then the restart button allows the game to begin again. Now, several ideas were intentionally excluded. These included multiple guard types, moving objects, upgrades, multiple maps, and even a story campaign. And keeping these features out allowed the project to stay focused on demonstrating the interaction between the 2 primary systems. And lastly, for my open questions, I identified several balancing questions, including the game length, the guard counts, vault noise growth, beacon strength, and cooldown timing. And most of these were answered throughout playtesting and iteration. And the final implementation does differ slightly from the original design because balancing was required more iteration than expected. Now, at an architectural level, the game is mostly built inside of Script.js. There we go. Now, the index HTML file does mainly provide the page structure like the canvas, the HUD text, the start button, and the restart button. The style CSS file is mostly just visual. It controls the layout, the colors, and button styling, so I'm going to ignore those 2 files. Now, at the top of the file, at the script file, I connect the JavaScript to the canvas and the HUD elements, and then I define the major game state variables such as game state, survival time, vault, and beacons. Now, the initial game function resets the whole game. It clears the timer, resets the vault, creates the starting guards, clears the beacon, and restarts the animation loop safely. Okay, yeah, there we go. The game loop function is the very center of this architecture. Every frame, it calculates the time, updates the vault noise, updates the cooldowns, removes expired beacons, spawns guards over time, and even updates the guard's behavior and also redraws the game. Now, the sound source system is mainly handled through the vault beacons, the place beacon function, the update vault noise function, update beacons function, and the get max active beacon function as well. Now, however, for the guard system, it's handled through the guards, the create guard function, the update guards function, the find sound target in range function, update wander target function, and move guard towards target function. And then the difficulty curve is supported by spawn guards over time, which adds a guard every 15 seconds, and then update vault noise, which gradually increases the vault sound level. And then finally, the drawing functions like draw vault, draw guards, and draw beacons are separated from the update logic so that the code is easier to explain. And then the renderer shows what the systems are doing, but it doesn't control the game rules. Now, as for the required question number 1, describe your 2 systems individually. The sound source system owns everything related to sound. It manages the vault noise, the vault sound radius, the beacon placements, the beacon cooldowns, the beacon duration, and the maximum number of active beacons. If this system existed by itself, sound would appear and disappear, but nothing in the game would react to them. However, the guard attention system owns the wandering behavior, the sound detection, target selection, movement, and collision with the vault. Now, if this system existed by itself, the guards would simply wander around the room forever because there would be no meaningful sound sources to follow. Now, for question number 2, trace the interaction between your two systems. The sound source system constantly creates the competing sound sources through the vault and player place beacons, while the guard attention system continually checks whether each guard detects one of those sound sources and moves towards the strongest one. Now, neither system can create the gameplay by itself. Therefore, the gameplay emerges because the player manipulates the sound, while the guards independently decide how to react. Now, for question 3, walking through the difficulty curve. Now, my difficulty curve has 3 main components. First, the vault becomes louder over time with the update vault noise function. Second, the spawn guards over time function adds a guard every 15 seconds. And then lastly, the player gains additional active beacons as border guards appear, keeping the game balanced while still increasing pressure. And these functions work together to gradually increase the amount of decision making required from the player. Now, for the last question, comparing my curve to my designed curve to what we actually see now. Originally, I expected the increasing vault noise just to be enough to create the difficulty curve, but during development, I found that the game was way too easy because the guards always moved directly toward the vault, allowing players to just repeatedly place beacons near the edge of the map. So I had to redesign the guards so that they would wander around until they detect sound, and then later add more guards spawning every 15 seconds. And then those changes made the gameplay much more closer to my intended design because players have to think more carefully about when and where to place beacons. Now, for the post-mortem reflection, the biggest success of the project was separating the game into two clearly defined gameplay systems, which made the architecture easier to explain and the gameplay easier to balance. The biggest challenge was balancing said interaction between those systems. Most of my development time was spent refining guard behavior and adjusting difficulty instead of creating new mechanics. Now, if I continued this project, I would improve the guard AI by allowing guards to briefly search an area after investigating a beacon rather than immediately returning to wandering. And overall, this project showed me that relatively simple systems can create interesting gameplay when they interact well, and that balancing those interactions often takes more time than implementing the systems themselves.